Alright, hello guys. Welcome back to another live stream. This is me, Totality. Hi yo. So, today what we are gonna do is basically we are actually gonna be taking up some work up here, alright? Now, you might be seeing me, you cannot see my face by the way, but you can see my table actually. Can you? I'm gonna actually this time thought of showing my face instead of doing it. So yeah. Also, I'm gonna keep my book here. If you don't know what I've been studying today and yesterday I was like studying a bit of physics practicals, because next week we have chemistry and physics practical examinations, and we have to actually study for both of them. For chemistry practicals, we have only one experiment, that is salt analysis. It's gonna be easy, but the thing here is that you have to be really very well prepared for that. So yeah, that's the thing. For physics experiments, we have six of them. Overall, I have completed like two of these, and still we have a little bit more timings, but I don't want to waste much more time, because we have actually still less time, because we don't want to go much less onto this. So let's just try to deep dive through it. We have overall now only 2 to 3 days. That's it, and that's how we'll actually start our physics practical examination. So anyways guys, let's just start off. We are gonna start off with Hooke's law, or because I've been thinking of starting from the easiest experiments. We have done vernier calipers and screw gauge. I've been thinking of starting from the easiest to the hardest ones. Hooke's law is overall very easy. It's fine, you can actually get the values nicely, but the problem from the Hooke's law is that there will be some errors, and these errors are caused by the position of the needle. You see, in Hooke's law, we have a needle that actually gives us the reading, but sometimes the needle is not actually positioned correctly, meaning that it's not inclined, or it's not coincident to the readings. If you actually observe it closely, the image is kind of pointing a bit downwards. It's kind of making some is inclination right there. I mean, and downwards, it's making some downward small directions, and actually that is causing some errors, by the way. So we need a really great experimenting apparatus that will actually provide us really great work to actually do it, because bro, like, actually this is not at all great. Like physics practicals, the apparatus is not at all good. There should be a solution based on this, like how we actually have solutions, like finding the zero errors, because there are errors in there, but then we don't have any idea of how we are gonna resolve the errors from the the spring constant. So we need to be really aware of that too. So I'm not sure whether I can discover that truth out. I'm not sure, because it's still a mystery how to actually solve. We didn't solve the mystery yet, so of course. Oh wait, did my cam glitch list? I'm not sure. Okay, anyways, we are gonna do Hooke's law. In Hooke's law, what are we specifically gonna be doing? We'll be finding the spring constant. The formula expression given by the Hooke's law is basically F is equal to kx. What I mean by here is that in this theory, or in this law, it states that the within an elastic limit, the restoring force is basically directly proportional to the I can say extension of the spring. So I can actually describe it as F directly proportional to X, or F directly proportional to L, and then I'm gonna remove this proportionality sign with the help of constant of proportionality, and this constant of proportionality is known as spring constant, or also known as the force constant. This spring constant or force constant is represented by the letter small k, or it can be also done by capital K. It depends upon the person if he uses it, but yeah, it's the letter K for sure. Then what we basically have to find in this experiment, or is basically finding the value of constant of proportionality. We have to actually get the value. Now we can get the value in two types. Okay, you can either get it by through the graphical method, which is another way, But then there is another method you can actually get it, that is by using the apparatus. So we'll be using the apparatus, we'll actually get this, then we will try to make a graph based on it. We'll find the slope of it and we'll calculate through graph. So basically what I'm saying is that we will be using the slope formula to calculate it, and not only that, we'll be using the main method. So alright, let's just start this off. First of all, I have to watch a video of how we are going to exactly use the apparatus, because the thing is that physics experiments we do are been done long while back, and it's actually really difficult to make that much better. So in order to make this a really great possible method for it, we need to have an idea of what we are going to do. Alright, so first let's start off with, you know, Hooke's law. I will first even have to go to toilet, so yeah, let me just, please give me a moment. Okay, I'm gonna come back. Alright, this is gonna take a bit of time right here. Let's go. Alright, we'll watch a video. Okay, do you guys want to see this? I hope this is not gonna be a copyrighted video. Basically, I'm just gonna react to it. I hope so, dude. Are you capable of, I'm not sure whether you can actually do this. If this gets copyrighted, then this is gonna be doomed. That's for sure, I know. So yep, wait for a minute. Let's just check out one practical video. Okay, now this is gonna be in English, which is gonna be much better, because usually I study through YouTube. So you know, I mean, what I mean is that I actually study through YouTube is that usually sometimes it's gonna be called by a language named as English, which I really love to study with. It's a really great language. If you don't know, it's just a combination of Hindi, where you apply it on an English medium subjects, like I mean, not in English medium subjects, it's called as English medium. That's it. You can check out any other styles. It's really interesting to watch it and learn through it. Anyways, uh, what else should we do? Let's check. Okay, give me some time. I'm gonna check it out. We're gonna do, oh dang man, simple pendulum. It's everywhere. Once I just started searching up, you know, the dang dude, it's everywhere. Like, bro, the way once I just started searching up for physics practicals, literally popped up the simple pendulum. I understand what makes a simple pendulum tough, but trust me guys, simple pendulum ain't that easy. Like, for sure it takes a lot of yeah, never mind. Anyways, what is going on here? There's something else going. Yeah, Hooke's law. Yeah, Hooke's law. I actually did see some actual experiments like this, but then the apparatus was so different. Like, some people had really different apparatus. Like, they had a scale instead of this, and so they had this too, but then they were so different. Like, I was so confused at first. So yes, let me just show you. Okay, let me just show you. I hope this does not get me copyrighted. I have to mute if there is anything like this. Let's start off with my display cam. All right, let's go. So this one, see, I want this kind of pin. You see that pin? Oh wait, yeah, see this pin, by the way. Oh no, why is it showing this though? So if you check on this video, it says Hooke's law experiment. Now if you actually closely observe the pin of this, it literally is coinciding with the readings, and that's what I want. Actually, I want this kind of apparatus. If they are giving me this kind of experiment, then I should have this kind of apparatus. That's what I really want. Anyways, let's start off. Okay, experimental physics. Let's do that. Experimental physics. Alright, dude. Yo, where is it? Okay, wait, we got one of these videos though. We'll check this out first. Okay, there was an ad. Oh, stop. I'm not gonna actually look at you. Aha, I stopped you for a reason. I actually saw looked at one of his thumbnails, and the apparatus is literally exactly the same. Like, not joking, it's exactly the same. Yes, see this one, exactly the same. I wanted to actually look at this one though. See, wait a minute, I'm going to turn up the volume a bit, and I'm going to also turn on the desktop audio so that you can hear it. Right, yes, I'm going to turn that out. Yep, here we go. Okay, oh man, like, see that? Do you see this? To find the effective length of the second pendulum, that is everywhere. Say simple pendulum, dude. Alright. Oh wait, I forgot.
In this video today we are going to perform one physics experiment from class 11.
Also shout out to experimental physics. You can look at his video. It's written as to find force constant of helical spring. Right now I did not add this in description. I should be adding that. But if you're currently watching my stream, you can look up to this video. It's the channel's name is Experimental Physics, and the video is to find force constant of helical spring.
And the aim of the experiment is to find the force constant of a helical spring by plotting a graph between the load and the extension. So this is basically Hooke's law that we are going to verify by the experiment.
Alright.
Okay. So here you can see the apparatus in front of you.
Yes.
What we need in this particular experiment.
This one, I'm not sure. Is that accurate? Let's see. Maybe.
We need one spring, जिसका हमें spring constant.
I think it is a bit accurate. Yeah.
Now this spring is attached with the pointer.
But then it's kind of bit tilted.
It's also attached with one vertical stand, जिसके ऊपर हमारे पास एक छोटा सा scale है.
Okay.
इस scale के ऊपर हम सारे extension के reading measure करेंगे with the help of the pointer.
Oh, okay, that is fine. That is
really
good.
नीचे
Wow.
एक और हैंगर लगाया हुआ है जहाँ पे हम फोर्स या की लोड यहाँ पे हम ऐड करेंगे. Okay, and by looking at the extension through this pointer, with the help of this pointer we can measure the reading. In this particular experiment we required a slot of 20 gram. You can have a slot of 50 gram also, you can have a slot of 10 gram also. We are utilizing the slot of 20 gram. Now, what is the theory behind this experiment? As we all know,
so it's total of 100 right there.
When you apply the force to the spring, you can able to see the extension in the spring. So as per the Hooke's law, the force is directly proportional to the extension, or the force is directly proportional to the displacement.
Yes. Okay.
If you remove this proportionality sign, that we have to introduce one constant that we call as a K. And K is known as a force constant or a spring constant. Okay, and that is what we want to find out in this particular experiment.
Yes.
So this is our equation. K is equal to force upon L. Now how to measure?
Bro, wait, guys, I just want to say that. Just think like I just want the YouTube algorithm to think that I'm basically reacting to it. Alright, I really don't like. I really don't want to steal your video, but I just want to react to it. I'm a student, by the way. I just want to, watch your video just like every other student does. Sorry if I'm actually doing this, but I just want to react to it, man. Like, that's it. I know you may be thinking, why am I doing this on live? Because um I'm a kind of person who thought of actually, doing a live is a better idea for me to study more. It gives me more motivation, more disciplinary acts to actually follow it. So please do not copyright me. I beg you, please do not do this. I really, really appreciate each and every work you do. Please do not copyright me, okay?
This particular value of k for the given spring.
I'm just
So
a
before
student.
we go for the experiment, we should note down the observation.
All right.
कि हमारे पास एक्सपेरिमेंट में जाने से पहले कौन कौन से डेटा है.
Okay. This
The
looks
number
easy.
one
Of
observation
course,
is
this is
the
easy. My
least
bad.
count of the vertical scale. तो आप यहाँ पे देख सकते हो ये vertical scale.
All right. Okay.
Okay. Now this vertical scale.
Wait, is it in centimeters or millimeters?
And the 1.
It
And
should
there
be
are
centimeters.
10 divisions between 0 and 1. Okay. So the value of the one smallest division on this scale, that is nothing but the 0.1 centimeter. तो ये
What happened?
They gave me useful insights and tips which helped me gain a 50-70 in the SAT. They
Okay.
gave me incredibly useful.
तो ये
Sorry for
exactly
that,
वैसा
dude.
स्केल है जो हम नॉर्मल रेगुलर कंपास बॉक्स में यूज करते हैं. सो द लिस्ट काउंट इज नथिंग बट द 1 mm, that is equal to 0.1 centimeter. Second, the slotted weights. In this experiment, we are going to use this weight slot that is of 20 gram each. Okay, so we will have this 20 gram weights, and we are going to measure total 5 reading with the help of this 5 20.
Yo, guys, can you hear me? That crash was so unexpected. I did not even get a notification of crashing out.
जरा बंद कर बता कैमरा.
Yeah.
वही कैमरा बंद कर.
Camera? Yeah, है ना? यहाँ है सर.
डाल के छोकरी.
यहाँ है.
ईशा हिबा हट जरा सामने.
क्या रूम से क्यों उठा हुआ है?
लग जाओ.
Okay. Oh, camera glitch. Oh. Stop that. I don't want that camera glitch. Like, dude, what? Sometimes this camera glitches a lot. That's the thing. It's a really bad thing. Wait, desktop audio is open. Wait a minute. No.
By ton.
Okay. Let's go.
To just increase the force on the spring. In second column, we have a reading of pointer, in which we have like 2 column loading and unloading. तो इनिशियली हम क्या करेंगे कि जो 20 ग्राम के जो स्लॉट्स है हमारे पास, उसको इस हैंगर के अंदर ऐड करते जाएंगे. तो ऐसे 20 ग्राम करके हम इसके 5 स्लॉट जो है हमारे पास उसको हम ऐड करेंगे, एंड वी विल फाइंड द एक्सटेंशन और वी विल फाइंड द डिस्प्लेसमेंट और वी विल फाइंड द रीडिंग ऑफ द पॉइंटर, जो हम यहाँ पे लिखेंगे. नाउ देन आफ्टर हम एक एक स्लॉट को रिमूव करेंगे. ओके, दैट इज नथिंग बट द अनलोडिंग. So in the case of unloading, initially we increase the weight and we'll measure the reading for the extension, and at the end we start decreasing the weight in the hanger, and again we measure the extension. And
Alright.
after doing this, we will take the average of both of them, and that is our final extension.
Okay.
Okay, so let us start this experiment. So here, before we go for the experiment, we should measure that this
Wait a minute.
experiment has a zero error. That we have to check. तो इसका जीरो एरर कैसे चेक करना है? तो हमें ये देखना है कि जो हमारा ये पॉइंटर है, वो पॉइंटर बिल्कुल जीरो पे टच हो रहा है. तो अगर ये पॉइंटर जीरो पे टच हो रहा है, मतलब हमारा जो एक्सपेरिमेंट में या जो बिगिनिंग में कोई भी एरर नहीं है. बराबर. अगर ये पॉइंटर टच नहीं हो रहा है, तो पीछे स्क्रू की मदद से हम इसको ऊपर नीचे करके जीरो पे सेट कर सकते हैं.
Oh.
But right now it is already on zero position.
Okay,
so we don't
I
have
should
any
note
kind
that
of
down.
error
I
in this
did
experiment.
not have any idea
So let's
based on
start
that.
with the very first reading.
Okay,
जब
this
हमने
could be the
zero
thing too.
load-
Yeah, I did not expect that. Whoa, yeah. That could be a thing too. Maybe at that time, the reason I actually, this could be one of the reasons though of for me to get some inaccurate values. Oh yeah, that could be it. Wait a minute. Let me just check, guys. Okay. Okay. Like, dude, what? This is perfect. Okay, nice. I like that one though. 2 minus 2 cos 30. The best method of doing it. Okay. All right.
यहाँ पे अप्लाई किया हुआ है, तो यहाँ पे जो एक्सटेंशन हो रहा है वो भी 0 सेंटीमीटर है, क्योंकि हमारा जो पॉइंटर है वो बिल्कुल जीरो पे दिखा रहा है. दैट इज आवर फर्स्ट रीडिंग. अब हम इसके बाद ऐड करेंगे 20 ग्राम स्लॉट.
Asana helps you identify
No,
blockers
no, no, I
to
don't want to
keep
show
work on
them.
track.
Oh, no, no,
Try
no,
for
no, no,
free.
I cannot show it. Sorry. Dang, dude, I hate these kinds of ads coming up like it. Bro, this could
Hello, I
ruin
am
the
Dr.
whole
Andrew
YouTube
Daniel,
stream.
head
No,
of
no, I'm so sorry, bro.
Now after adding the 20 gram slot, just wait for a second. Okay, कि आपकी स्प्रिंग थोड़ी बहुत ऑसिलेट होगी. You have to wait कि ऑसिलेशन आपके बंद हो जाए, and then you have to take the observation.
All
Now
right.
you can see or you can check the reading of the pointer. If you check the reading of the pointer, it is on the like a second digit or seventh digit from
1.8?
the 0. Okay, that you can check.
Either
So
could
our
be
first
1.8
reading
or
for the 20 gram,
1.7. It looks so
that
it's
is- that is
1.8.
nothing but the 0.7
What?
centimeter.
Oh my bad. Okay, whoa,
Similarly,
whoa,
add-
whoa, 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 whoa. Chill out, chill out. Why did I even say 1.8? That was really
Second
bad.
digit
Okay.
or seventh
My
digit
bad.
from the 0. Okay, that you can check.
Okay,
So our
0.7,
first
my
reading
bad.
For the
Oh.
20 gram.
Dang, okay, next time I'm gonna
That
do
is-
this
that is
again for
nothing
sure.
but the point.
Man, I'm already
7
trash at
centimeter.
making readings, huh?
Similarly, add
No
again
way. I hope so. I don't make any silly mistakes. You have to do this very slowly.
one more 20 gram. So total is 40 now.
Okay. इधर
Now again you can look the
रुको जाओ मैं Why, dude? This is already off to a bad start. I knew it. This was gonna happen. Damn. Not even 1 hour and it already happened. I cannot even live stream, dude. Like, dude, why? I also need my phone, though. I cannot stream through it. Also, it says 0 kbps. Damn. Really, dude? Yes, man. Today's live stream is going really crazy. I cannot just show it normally. Oh no way, dude! I gotta end this stream now. They're saying that I have to give the laptop for an important work. The problem is I don't have any of my own laptop. This is a laptop that is used by the whole family. Just imagine, dude. I'm using it for 6 to 7 hours. What are the rest of them using for? Like just not kidding, dude. Dang. Anyways, guys, gotta go now. I'll be studying off cam now, I guess, because I might study through my phone. But the problem is I need to watch YouTube through, on my phone using experiments. But if I have more mobiles access, then I will. So yes, maybe after dinner or somewhere else. I'm not gonna do dinner right now. I'm gonna study, of course. So yes, I'll come back. Bye for now.